also known as dimensional analysis. We use this method in all of the sciences, or even in math classes, to change when we know one unit, we want to measure something in another unit. For example, if you know your weight in pounds, but you have to record it in kilograms, how do you do that? Well, it starts with a four-step method. These 4 steps you're going to hear me repeat over and over again throughout our chemistry program because they are the 4 steps to the unit factor label method. Start with what you know. What was the given starting point that the question gave you? We put the unit that we want on the top of the line, the units we're getting rid of on the bottom of the line, and then what we do with the numbers is multiply across the top, divide across the bottom. Now these 4 steps, as I just read them, seem a little abstract, so what I'm going to do is work our way through a series of examples for you. Suppose that we know that there's 2.2 pounds in every 1 kilo. That's something that we'd call a truth. These two values are equivalent to each other. I could put 2.2 pounds on one scale, and I pick it up and put it onto a scale in metric, it would tell me I had 1 kilo. Now we also know from math that anything divided by itself is equal to 1. So if I take 2.2 pounds and divide that by 1 kilogram, I get a value of 1. At the same time, if I take 1 kilogram and divide it by 2.2 pounds, because they are the same value, again, I get a value of 1. Now this is called special 1 because we're obviously mixing matching units here, but it is mathematically going to work out to a value of 1, anything divided by itself. And we also know that anything times 1 is itself, so this is kind of the essence behind why this procedure will work. Take a look at this problem. Suppose we have a bag of sugar that weighs 5 pounds. How many kilograms would it weigh? When I look at any problem in any kind of science class, look for the given values and the units accompanying them. We're starting with 5 pounds. That's the what you know. So the first thing I'm going to write down is that I've got 5 pounds, and I write down the number and the units. It's really important we don't drop the units here. They're a key part of the process. Then I'm going to draw a big long line, and I'm just going to cut it off. You're going to see a lot of people do this as a series of fractions, and they're just going to write a times, times, times instead of this vertical line. But I like the vertical line because my handwriting's messy, and I find this gets to be neater. Either way, it's the same idea. Now, I want to put the unit you want on the top. Well, the unit that I want is kilograms. So that's what the question asked me for. You always want to put the thing you're looking for on the top. So I'm going to put the unit kilograms on the top. You'll notice that I've saved this big space for a number. That comes in a minute. I'm going to put the unit that I want to get rid of on the bottom. Well, I don't want my answer in pounds, so I'm going to put LBS, or pounds, on the bottom, because from top to bottom things will cancel. Again, I've left a big space here for a number. This space that we have right here, this whole column, kilograms over pounds, is our truth. And from the last page, we know that every 1 kilogram contains 2.2 pounds. That's truth. So pounds on the top cancels pounds on the bottom, and I would be left with the units kilograms. So whatever I do mathematically is going to give me an answer in kilograms. It's the only one I haven't crossed out. And that is what I want, so I know I've set this up right. What do I do with this mathematically? Multiply across the top, divide across the bottom. We will say 5 times 1 divided by 2.2, or I can mix this up into any order. I could say 5 divided by 2.2 times 1. It doesn't so much matter so long as you hit times in front of all the numbers on the top of the line, you hit divide in front of all the numbers on the bottom of the line. Either way, you're going to come out with the answer of 2.27 kilos. What if I wanted to go the other way? Suppose we weigh ourselves on a metric scale. Maybe you're at the doctor's office and they weighed you and they tell you weighed 68.2 kilograms. Well, what would that be in pounds? Most of us don't know what that value would be. Again, start with what you know. In this case, I know my kilograms, so I'm going to start with my 68.2 kilograms. Write the units down. And then I'm going to draw a big long line, and I'm going to cut it off. Put the units you want on top. I want to get my answer in pounds. Put the units you're trying to get rid of on the bottom. I'm trying to get rid of the units kilograms. They go on the bottom. Now I try to find the numbers to make this true. And again, we've already discussed that every 1 kilogram, so I'm going to put the number 1 beside kilograms, is equal to 2.2 pounds. So I'll put the number 2.2 beside pounds because I could write these with an equal sign between them and it would be just the same. Made my line a little bit long there. All right, again, what do we have happening here? Kilograms on the top cancels kilograms on the bottom, so my answer is going to come out in pounds. So when I do the math, my answer is going to come out in pounds, which is what I want. So that's wonderful. We know that this is working. What do I do with my numbers? Any number that are on the top of the line you multiply, any number on the bottom of the line you divide by, so you'll go 68.2 times 2.2 divided by 1. And again, we don't really have to multiply or divide by 1 because it doesn't change anything mathematically. And you would get 150.04 pounds. Now, a lot of times kids will look at this and they'll say, well, it's either timesing by 2.2 or dividing by 2.2. So I'm just going to memorize that. Well, you can. Sometimes you'll find you're not sure which way is the right way to go, but not all truths are as nice as that. Take a look at this truth. In our unit that we're going to be working on the gas laws, one of the truths we're going to use is that 760 millimeters of mercury is equal to 101.3 kilopascals. These are both units of measuring pressure, like how much pressure a gas would be putting on the walls of a balloon. If I was giving you a value of 20.03 kilopascals, and I told you that to do a problem for me, you had to change that to millimeters of mercury, how would you do that? Well, you'd start with the same steps. Start with what you know. What is it that we know in this question? Again, we know that we have 20.3 kilopascals, so that's what I write. I'm going to write 20.03 kPas. And then I'm going to draw a big long line, and I'm going to cut that off, or I'm going to write a time sign, whatever makes us happy. Put the units you want on top. The question is asking me to solve for millimeters of mercury, so I'm going to put millimeters of mercury on the top of the line because that's what I'm trying to solve for. Put the units you're canceling. It's usually the unit right there is going to go down on the bottom. So kPa goes down onto the bottom. Just the units. Just put the unit. We don't put numbers yet. Once we have the two units top and bottom, I look for something to make them true, so I'm effectively multiplying by special 1. What is true about millimeters and kPas? Well, this is what's true. 760 millimeters of mercury is the same as this in kPa. So I'm going to put my 760, oops, excuse me, try to fix that up there. My 760 millimeters of mercury and my 101.3 kilopascals down on the bottom. Now, as we take a look at what's going on here, kPa's on the top cancels kPa's on the bottom. So the only unit I haven't crossed out that hasn't canceled is millimeters of mercury. I know my answer is going to come out in this crazy looking unit, millimeters of mercury. What do I do with the numbers? Multiply numbers if they're on the top of the line. Divide numbers that you find on the bottom of the line. Hit equals when you run out of numbers, guys. You can go 20.03 times 760 divide 101.3, or you can go 20.03 divided by 101.3 times 760. The order doesn't matter. Multiply and divide don't have a set order of operations. Regardless of how you enter it, you're going to get to a number of 150.27. So I hope this little short video helps. Again, start by looking for the number that you have in the question. That's the what you know. And then look at the units attached to it. The units you're getting rid of will go over into the bottom. The units you're solving for go up on the top. And the math is the same. We're going to use this procedure over and over in several units. In chemistry, we'll be using it in our gas laws unit, our stoichiometry unit, our solutions unit. It's a really handy way to convert between any two units where you know what the truth is.